Shut that off. All right, on to number 5. Number 5, we will solve by graphing. So the first thing we'll do is we'll set it equal to 0. So far, you're going to solve by factoring it needs to be set equal to 0. Same with graphing needs to be set equal to 0. So we'll take this 2x squared plus 4x minus 70 equal to 0. So you're going to rewrite it, set it equal to 0 if you need to. Rewrite it, you can. If you just want to do it in your head and then just start putting it into your y equals, that's kind of up to you. So next thing I'm going to do is take out my calculator. So we'll close this down. Get this here, get the calculator back up. All right, where are you? Oh, start. And there it is. So to solve by graphing, we are going to start by putting our equation into the y equals. So 2x squared. If you haven't found this x squared button, it's diagonal from the 7. That's the better one to do. If you hit this caret button, it's going to leave you up in the exponent, which is really annoying because then you keep typing stuff and then it's all in the exponent. So if you hit squared, it just bumps you over. Okay, so 2x squared plus 4x minus 70. Then you can hit graph. If your graph is not 10 by 10, like maybe you're trying to find a vertex in a big problem or something, you're going to hit zoom 6 to get back to that standard window so you can start to see where your zeros are. So a couple ways we can find the zeros. You can go to your table, second table, and then you're going to find out where's y equal to 0. So there's one right there. So one of my solutions is 5. And I saw one on the negative side, so I'm going to go up to where x is negative and find where that is 0. So negative 7. So there's my two solutions, negative 7 and 5. So remember, I'm trying to find the zeros where those x-intercepts are. So I'm trying to find where is y equal to 0, because that's the coordinate where y is equal to 0. Dimension mismatch. Head to your y equals. Yeah. Go up to the plot. It's probably black. You want to hit enter, turn it white. Oh. Now hit graph, and then you should be able to see again. Yeah. So if that doesn't work, let me know. We could try something else. That worked. Okay. And then zoom 6 if you need to change your window, but there it is. Now the other way to find zeros, sometimes they don't go directly through an integer. So we're going to go second calc. I'll slow down a little bit. Second calc, which is the trace button. Go to 0, hit enter. So now we're looking for the 0 using this calculate option. Now I don't see my little blinky blip, and it's kind of hard to see for you guys. We're at negative 70 on my y. So if I start to move this, looks like I'm getting further down into the negatives. Now I'm starting to come up. So I'm just hitting left, left. Now I'm at negative 56. Now I'm at negative 34. Here we go. It's coming up. There it is. Left bound means I need to get somewhere to the left of the 0, which would be up here. I'll hit enter. Right bound, get to the right of it. Hit enter. And hit enter a third time. And that'll also find you your 0. Now the zeros were right in the table. We don't need to do that left bound, right bound. But if you have an x-intercept that's somewhere in between two, then you want to use the calculate 0 option. You guys want to try that one more time? Do that one again?
For me, on the negative side, it's not actually getting x equals 0. So it's just kind of going in between them.
Okay. So did you get like negative 6.9999 or something?
Negative 0.725436.
Okay.
And positive 2.9 or something.
So you might have put in a different equation than we did.
No,
okay.
Because on the positives it shows up at 0.
Okay. I will, why don't you just leave that equation in there? We're not going to use our calculator anymore after this, and I'll come in and check that one out. All right, we'll do the second calc one more time. So we'll go second calc 0. And our blinky thing is over here. We want to go across the vertex. So we got to go all the way around. And then it's going to start coming back up. So you're looking at this y to kind of see where it is. Left of it will be right there. Right of it will go above it. So now those two lines are in between. The 0 is in between those. Now I can hit enter again. And there's my 0, x equals 5. So there's going to be the two ways we can kind of check on our calculator. So the table is nice when they're just nice integers, but if you don't have the integers, you got to go use that calculate button, which is kind of annoying, but it's the way we can find it. So there's our first three methods. So we're going to move into the next section. You guys okay? Should we move on to the next section? If you have calculator questions, you can practice any other ones. I'll come around and help you out with those as well. And then Seth, just keep yours on there and I'll check it out here in just a second. We're almost finishing up here. All right, 4-6 and 4-7. So now that we've kind of introduced all these different methods to solve, it's kind of up to you guys how you want to solve it. So we're gonna check out number 8, just kind of checking really quick, looking at number 8. It's not going to be easy to factor, especially when the a value is greater than 1. It's going to probably take more time figuring out how to factor than it would be just to use the quadratic formula. So I've spent my 10 seconds looking at it and decided, nope, I'm not going to factor it. Let's move on to quadratic formula. So quadratic formula, we need to be set equal to 0, which we are, and then there's our a term, there's our b, there's our c. So we'll take opposite of b, which is positive 5, plus or minus square root, negative 5 squared, minus 4 times 2 times 1, all over 2 times 2. So we're going to start by inputting everything into the quadratic formula. Opposite of b plus or minus b squared minus 4ac, all underneath the root, over 2a. From there, start by looking at your discriminant. So just figure out what's underneath the radical, because if it's negative, we're done. We're not going to move on to finding the imaginary because section 4.7, we didn't do that yet. So we're going to check the discriminant next. So it looks like you're going to have a 25 when you do that negative 5 squared minus 8. So 25 minus 8 is 17. So we're going to have 5 plus or minus the root of 17 over 4. Now we've got 5 plus or minus my root of 17 over 4. I'm going to check the root of 17. It's not a perfect square. It's also prime. So the root of 17, I can't do anything else to simplify it. So I'm just going to leave it as a root of 17. I'm not going to change it to decimals. Okay, that's going to be a mess because it's going to be irrational. So I'm going to leave it as the root of 17. If I was looking for like a cost of something, then I would change to decimals, but I'm not. I'm just solving it. But the last thing you can do anytime you have the quadratic formula, it's going to form this heart shape if you indent right on that plus minus. And anytime you have a heart, you can tear it apart. If you have a heart, you can tear it apart. The denominator is going to go to both pieces of the numerator. So 5/4 plus or minus the root of 17/4. That'll be our final result. That's a Mr. Stoic quote. With the heart, you can tear it apart. It's also a dating advice. Later on, we'll talk about butts. Sometimes you get butts. And we'll talk about what we do when we get butts. But we get hearts. Anytime you do the quadratic formula, you get hearts. Tear them apart. You can take it into two separate. Now, if that root of 17 could simplify down, I would clean that up. That's a prime. I kind of like it. Sometimes you get a prime, you're just like, all right, I'm done. I can't do anything, so I'll just leave it. But if it was like a square root of 24 or something, we'd have to simplify that now. So there's your quadratic formula. Lastly, we'll look at completing the square. I'm going to be really transparent with you guys. Completing the square is a method to solve, but you can always lean on the quadratic formula. You're going to get the same results doing that, but we will just show how we can complete the square as well. So you can always lean on completing on the quadratic formula. So completing the square, it does kind of nullify after you learn quadratic formula. So to complete the square, we're going to get it into this form: x squared plus bx equals c. So we have to get our x squared and bx part on one side and move the constant over to the other side. So right now, factoring can't do it. Can't multiply to 17 and add to 8. 17's prime, so it's just going to be a mess. So we're not going to do that. So we're going to go x squared plus 8x plus something. Here's where I'm going to complete it so I can factor. It's going to equal 17 plus something. So completing the square, what it does is you're going to make your own trinomial that does factor. So right now I have an x squared plus 8x plus something, which I'm going to need to find that something to make it factor, equals 17 plus something. Now the reason I have plus something over here is when I add this to make it so it factors, I have to balance my equation. I got to add it to this side as well. So I'm adding it to both sides of my equation. I got to make sure that I do that. Just kind of basic pre-algebra. Got to make sure things are balanced. Now to find my missing piece, I'm going to take that middle term. I'm going to divide it by 2, and then I'm going to square it, and that's going to give me an answer of 16. So to complete the square, I'm going to cut my middle term in half, make it 4. Then I'm going to square it, and that's going to make it 16. Here's what you did. We just kind of worked backwards from how we factor. If you have a 16 here now, thinking about how you factor, how can you multiply to 16 and then add to 8? What number are you going to use to multiply to 16 and add to 8? Or another 4 and 4. So really, whatever it is to complete the square, it's going to be half of whatever that middle term is, 8. So 4 times 4 will be 16. 4 plus 4 is going to be 8. So you're just taking that middle term, you're using that to complete the square. The other thing we have to do then is add 16 to the other side. And we'll get now x plus 4 squared equals 33. Because you just told me 4 and 4 are the two numbers that multiply to 16, add to 4. Now we'll square root both sides. X plus 4 is going to equal plus or minus the root of 33. Subtract the 4 over, x is going to equal negative 4 plus or minus the root of 33. There would be my two solutions. So it's kind of sneaky. We do have two solutions because we'd have negative 4 plus the root of 33, negative 4 minus the root of 33. Those would be our two ones. If you went and did the quadratic formula with that one, you'll get the exact same thing. Everything will be exactly the same. So if you're more comfortable with the quadratic formula, okay, that can be a method you kind of lean on as you're solving your quadratics. Because they all are going to solve the same answer, it's just you have different choices of how you do it. But it's like taking a road trip. If you're driving to, say you're driving down to Mexico for spring break, it's a little bit easier to get down to Mexico taking Highway 35 rather than going like down to Florida, then across the Gulf of Mexico, all that kind of stuff to get there. So there's always going to be the same destination, but different methods of how you do it is going to make you get there a little quicker. It's kind of like the path you take when you're going on a trip. It's the quickest way I can get from A to B. So as you get more experience with that, you'll get better with how you can solve these out in the most efficient manner. We'll end that right there. The rest of the time that is yours. So we've got about 12, 13 minutes to continue to work on the review. I'll be available today for questions after school or things, but tomorrow I will not be able to answer any messages.